Year 13 short revision video number 8. So we have a question which involves trig identities and trig integrals here. So part 1, we need to show that 8 multiplied by sine squared x cos squared x can be written in the simpler format on the right hand side. So we can either start with this and show that it can be broken down into 1 minus cos 4x, or we can start with 1 minus cos 4x and show that it can be rewritten as the result shaded in green. I'm going to start with 8 sine squared x cos squared x, and you need to remember that this process can be done in multiple ways. There are different ways of proceeding here. So 8 sine squared x cos squared x, I'm going to write that as 2 sine x cos x multiplied by 2 sine x cos x multiplied by an extra 2 there. So you can see the two are equivalent. Now, let's take a look at this. 2 sine x cos x, which appears twice, can be rewritten as sine 2x using a double angle formula. So that is sine 2x multiplied by sine 2x multiplied by 2. So far I have 2 sine squared 2x. Now, we're then going to just diverge for a moment and think about the result for the double angle cos 2x, which can be written as 1 minus 2 sine squared x. Now, I can then double all of the angles that are involved here. So where, for instance, I have cos 2x here and a simple sine x, I can rewrite the whole identity but double the angle. So cos 4x, I'm replacing 2x by 4x. This would then give me cos 4x is equal to 1 minus 2 sine squared 2x. So x is being replaced by 2x, or 2x is being replaced by 4x. I can then rearrange this, so it tells me that 2 sine squared 2x is equivalent to 1 minus cos 4x. Well, where have we seen 2 sine squared 2x previously? It's over here. So this is equal to 1 minus cos 4x as required. So part 1 is done, and part 2 requires us to integrate sine squared x cos squared x. So the integral of sine squared x cos squared x with respect to x is 1/8 of the integral of 1 minus cos 4x with respect to x, because of course this result here is missing the factor of 8 there. So I'm going to leave the 8th outside the integral sign for the moment and just integrate both parts inside. So obviously 1 just integrates to x, and then I've got to integrate cos 4x. So that's going to integrate to 1/4 of sine 4x, standard integral result, and then we mustn't forget plus c at the end. So the final answer is 1/8 of x minus 1 over 32 sine 4x plus c.